Hello, my name is Brian Kelly. I am the CEO of Emproof. It's an embedded security company. So we're not focused on the network, we're not focused on penetration testing, we're not focused on those ideas. What we're focused on is protecting the devices themselves in an embedded solution. So whether it's automotive, aerospace, any of those types of fields, medical devices, telecommunications, anything where a customer really needs to protect the value contained in those embedded devices. That's where we focused on. Our story really starts with our team. So it started in Bochum, Germany, coming out of the Ruhr University Bochum, which is one of the top embedded security programs in Europe, probably in the world. And it starts with our 3 PhD candidates and postdoctorals doing research in the field. That's Tim, Mark, and Philip. Mark is here with me today. And they were supported by two of their professors who are up on the board, Christoph Parr, who is now the managing director of the Max Planck Institute for Cybersecurity in Bochum, and Thorsten Holtz, who is also a professor at the Hertz Institute for Embedded Security. Two well-known, worldwide well-known experts in the field were supporting the team during their research. And they came up with a question while they're doing the research. They were focused on finding ways to exploit the software, ways to penetrate. Where were the weaknesses in embedded security? And it was too easy. They asked, why is this so easy? They could break into just about every system out there with a minimum of effort, and then they were looking at ways to exploit and notify the companies and how to do that. But they started thinking, really what we need to do here is find a better way to accomplish this. And they decided to ground Emproof. They started off working on a basic premise. How do we do this? They turned it into a product. They got government funding from Germany for the research. And then we decided to commercialize. They brought me on as CEO. We brought David Rose on as sales, both of whom have years of experience in startups and scale-up companies. And together, we have the capability to provide the business expertise and the technical expertise to bring this to market. Where's the problem with embedded devices? There's two ways they can be exploited. Well, you can exploit them, hack into them, exploit the technology, steal the data, compromise the units or the networks and the devices themselves. And you can also steal the IP. The software itself has value. The IP within the embedded systems has value, and they can also be compromised. So if you're selling into a zero trust market, you really need to protect that. This is especially important with machine learning, AI algorithms, and models that really need to be protected and have value. So we can protect, our system will be able to protect both of these, or can protect both of these. In software security, what we have developed is a software program. It uses a binary transformation process, so it's completely independent of hardware architecture, of software language used, or the compiler. It can be used across any of theirs. No limitations on where it can be used. As long as the engineers have designed for a particular hardware architecture, we can deploy it. We provide both the IP security and the exploit mitigation. Other companies are providing one or the other, but the real secret to what we're providing here is we can provide this in a very small footprint. 10% overhead on average. Now, when you think that on software protected programs, usually they'll have 1,000x overhead, they can't even be used in these embedded environments. But we can take this down, put it in there, and this is done over years of, this has been accomplished over years of research. We use a combination of techniques, so it's not just one technique that we put in there. We use code obfuscation, we use anti-fuzzing, there's platform security elements to it, anti-tampering and exploit mitigation elements, all use different techniques. So there's a combination. If one of those techniques can be, if an attacker or someone coming after the program can exploit one of those techniques, there are backup techniques to protect the software and the program. Again, all of this within a very small footprint, which also means very low latency. Our business model is pretty simple. We're going to lower your project costs. We're going to help you release valuable resources for other options, and we're going to help you to develop your products faster. Why is that? Everyone has a shortage for engineering, especially for security engineers, especially for embedded security engineers. There aren't many out there. we can give you an automated process to provide security for all of your embedded systems. You don't have to worry about adding that on at the end of your development process or before you deploy. We can do that. It's a subscription model, so you'll be able to pay annually, download, and use. We'll be working towards two models here. We'll be working on a customized model for high security applications, people that need more proprietary solutions. But our main model, within 18 to 24 months, will be simply get on the site, download it. As long as you're using an architecture that we've developed for, you'll be able to run it and use it. Competition, talked a little bit about this, that most of the competition is they're either going after IP protection or exploit protection, but the main competition for us is in-house solutions. Most companies are still using in-house resources to develop they're using it on a project basis, so they're developing security for each individual project separately, and they often don't have the in-house expertise to develop deep security. And what we've seen, we haven't seen anyone anywhere near our overhead capacity and performance levels. Milestones, 2016, the company was founded as a research company in Germany. 2018 received a grant for 1.3 million euros from the German Ministry of Education, which they used to turn the concepts and the scientific research into a product. Since 2018, they've been working on taking that idea of the product and learning how to make it scalable, which is a big challenge, which we've achieved. So this product is easy to scale, easy to download. As I said, we can use it across multiple platforms. 2022 is our commercialization year, which we're in the middle of. We're bringing on our first customers, our first paying customers. We've got a number of POCs that we're working on. We brought in our commercial team. We've secured our first round of seed funding, and we're ready to go in 2023. 2023 will be more expansion in the commercial side and working on two areas for future development. One, as I mentioned, is this downloadable version of the product, where you'll be able to just get on, run, and go, which is more for large volume users. And then the other area that we're working on is a device binding technology, where we'd create an interface that would lock our software to a specific hardware function. This has been very interesting. We're talking to the number of semiconductor companies about this, who are becoming more and more reliant on firmware in their applications on their semiconductors, and they need to protect their firmware and protect the integration of the firmware with their hardware, which is something that we can help with. So that's the company. We are looking forward to have the next couple of years of really building this and developing it. We're going to be continuing to do more development. We have a heavily scientific research-based team. We have four of our 7 team members right now are either PhDs or about to receive their PhDs. We're going to continue with that. Our goal is to always stay ahead of where we are scientifically, but we also want to make sure that whatever we do, it's scalable and easy to implement. Thank you very much for your time. Take any questions you have.
Doesn't modify the way the program is
Good question. So it's just something I should have mentioned in the presentation. So one of the other unique features of what we're doing is that we are the only functional safety certifiable program out there that we know of in this field. So Mark, who's here, and his team, when they started designing this, Mark comes from a hardware background and a mathematical background, and they formulated the software in a way that using the TÜV standards and other functional safety standards that it would meet those requirements. We're in the middle of the TÜV certification process right now for the automotive standards, but everything has been designed with functional safety in mind. So by those functional safety certifications, going to the company and show that we are not going to adversely affect the functioning of your software. And that's a really important thing, especially in aerospace, automotive, medical devices, where we can't afford to have any effect on the functionality of the software. So we've thought about that from day one on the design of the software, and it's fully integrated into our program.
You are able to be 100% confident that there are no alterations of the normal functioning of the software?
We're going to be 99.9. I'm not going to say 100. No one ever does. They'd be crazy to do that. So, but I said we have developed the software in a way to meet those functional safety requirements. We're constantly testing in-house. And we will do, for companies, especially in high security applications, we are happy to do a POC and have them fully tested. No problem at all.
Okay, thank you.
Mm-hmm.
Just a question of your client profiles. Could you tell us a little bit more about that? Is it SMEs or blue chip companies?
Yeah, so the product can be used in any embedded application that runs software. So that gives us a wide range of plays to go here. What we focus on are 4 strategic verticals: automotive, aerospace, medical devices, and smart cities, smart infrastructure. Those are our 4 keys, and those are the 4 keys because we see a lot of growth there. We see a lot more reliance on embedded systems and the need to secure those embedded systems, those extras. 2 other areas that are related because they sell into those markets are semiconductors themselves. I'll be honest with you, I came out of a semiconductor hardware company before. I thought we would be more focused on the systems integrators, the middlemen, but our conversations with the semiconductor companies thus far has shown a real interest in what we can do with the firmware. And that is an area, especially for that device binding application that I mentioned. The device binding application, we have the concepts there, we have the design ideas there. We are just, when we start getting some more money in, we'll be able to do the tests. We're also working with a couple of potential customers on joint programs that will involve device binding. So that's an area on the hardware protection. The other area is protection of the AI and ML models. We don't see that going anywhere anytime soon, as these are our previous speakers we mentioned about where they are. And as they expand and become more widely used across all industries, those models have value. And those models are going to be, people will either be trying to steal the results of the models or try to copy the models themselves. It's already happening. And that is something that we can help with. We can protect, harden those models themselves against exploitation, especially selling into markets where that may be a risk.
Oh, just ask, how many are you? And
so we are 7 at the moment.
7? Okay.
Starting in January, we'll be 10.
Okay.
And that is a summary we have. At the moment, we have 2 commercial and 5 technical. We'll be hiring 2 more people on the commercial admin side and another technical person in January.
Okay. And just what makes the difference
Difference in?
Compared to other products, equivalent products?
Yeah, our
you spoke about overhead. Is it overhead or is it more than that?
Yeah, our biggest differentiators are really, it's overhead. So the fact that we can do in a 10% overhead capacity area what other companies need 100 times more overhead to do means that you can deploy our security in environments which normally you wouldn't be able to deploy advanced security because the constraints are too. Now, both in memory, but also in power, right? A lot of these IoT applications, a lot of the industrial applications are running on battery power on low overhead. So the overhead drags on the battery and the power as well. So by limiting the overhead, you're really limiting that. The other area where the low overhead makes a difference is lower latency. So we're able to run in real-time operating systems where you can't even have a millisecond of delay, which could cause a problem, especially if you're looking at smart infrastructure, aerospace, medical, those types of applications. So the overhead is the biggest differentiator. The other 2, functional safety, the fact that we've designed this product by embedded security experts, specifically for embedded security with the idea of functional safety at its core. So we want to show that. That's another differentiator. And the third one is the flexibility of integration. We can be integrated at the design phase, we can be retroactively integrated as long as the product has an upgrade potential and runs software. They're upgrading the software. We can be integrated retroactively, and we can be integrated at any time during that development process. And that also, no hardware restrictions, no software code restrictions, because we're using the binary, and no compiler restrictions. Some of the other companies out there, they have to use a specific compiler. So you'd have to switch your compiler, change your processes. That's not the case with us. You can use whatever compiler you're comfortable with, whatever programming language you're comfortable with, and whatever hardware architecture. We are headquartered in the Netherlands, and our engineering center is in Germany.
Thanks a lot.
Yeah, thank you.